Good morning. We are representing the TRIP project, the Transform Reduced Input Potatoes project, which has been funded by Innovate UK over the last 3 years, which is concluding in March. The objectives and I'm joined today by Dr. Katherine Steele and from Bangor University, and Chris Dustow, who runs a farm with his wife Claire in Colwith Farm Potatoes in Cornwall, who have been part of this project. So you can see behind me the partners involved. The project has been led by Dyson Farming Research based in Lincoln, and we've had participation from the James Hutton Institute, Bangor University, Light Science Technologies, ourselves, Emerald Research, and SDF Agriculture, and farmers, Colwith Farm Potatoes, and FG Pryor and Sons, and Slatton Ridden Farm, also all in Cornwall. So before we get going, just a little bit of housekeeping. There's no fire alarms tests today, so if you hear the fire alarm, run. By now you'll know where the toilets are, so I don't need to tell you about that. Can you put phones on silent if you haven't done so already? And basis and NSRO points will be available on exit on the way out if you want those as well. So what we're going to do today is just sort of cover the various aspects of the project that has been running over the last 3 years. But in broad outline, the objectives of the project were to look at varying ways at which we can tackle essentially carbon footprint and also soil health in the crop of potatoes. In other words, reduce the impact of growing potatoes, but importantly, without reducing yield, and even more importantly, hopefully maintaining profitability given any season for the grower as well. So profitability is obviously one of the most sustainable things for all of this, because if you're not doing that, then the rest of it is not going to follow. But it's about sustainability in all its senses, reducing inputs of all types, reducing the impact on the soil, trying to increase or decrease the impact of cultivations as well throughout the entire project. So we had different strands running, trials running at Dyson Farming up in Lincolnshire, their trial sites there. Some of you may have visited Potato Days last year. You will have seen some of that going on there. And we've also had parallel plot trials running at Bangor University of different sorts, both those of nutrition and also plant breeding as well. And those looking at reducing greenhouse gas emissions and measuring the emissions, reductions in emissions, which we'll come on to, but that is actually one of the most important aspects of this particular project. So I'd like to start with ourselves, what we've been doing, and our objectives have been to use our integrated OptiYield system as the foundation and basis of the crop nutrition, developing crop nutrition. The objectives of the system are combinations of, first of all, soil analysis, reimagining soil analysis from, if you'll forgive the pun, the ground up, and then using that as the basis to create a series of interventions, both soil applied and foliar, using biologicals and biostimulants, and some biopesticidal activity as well in combination. So we've done that through research in the glasshouse, you can see behind us, and field trials, strip trials, plot trials at both Lincoln and at Bangor, and through laboratory work where we've been developing new biostimulants, new nutritional mixes. The combination that we have, it does involve foliar. One of the issues with foliar has often been that you may have a foliar product which will, on the face of it, contain nutrients that you need, but delivering those into the plant in a way that doesn't scorch the plant or damage the plant, and that the plant is able to take up, is a whole other step. So that's part of what we're doing. So you'll see on the left-hand side, which we'll cover a bit later, a device that we've been developing with our partners, Light Science Technologies. This is a world first. It's a greenhouse gas detector that actually detects emissions, particularly nitrous oxide emissions from soils. And it's a world first because the only other devices available are essentially static research-based devices that are designed for essentially a slightly different purpose. These are field deployable, practical, stick it in the back of the Land Rover and go and put it out in the field devices. And they integrate through the mobile network with other software systems, so we can measure in real time greenhouse gas emissions, nitrous oxide emissions, which also means lost nitrogen, lost cash in terms of nitrogen applications in the field. So we'll come back to that. This is what you see behind you behind me is the outcomes of one of the first trials we did with F.G. Pryor and son, Philip Pryor, and his family in just outside Truro in 2023. And again, the objective here was looking at low input based fertilizer. So instead of the standard rate of fertilizer, we're putting in half rate fertilizers. So it's literally half rate NPK in the seed bed. Take the standard recommendation, cut it in half. And then at planting, either the application of a multibacterial compound with biostimulants on the seed at planting, and that is instead of things like Amistar and Maxim, etc. So we've got that as well, comparing half rates with and without those bacterial inputs, and then foliar applications or not. And then finally, the last one is the comparative, which is conventional, which is Amistar and Maxim at planting, a full rate fertilizer, so using the full rate of standard conventional fertilizers, and then a full chemical blight program. And as you can see from the results behind, where we were using half rate fertilizers plus the foliar, which is the numbers 1 and 2, if you're looking 1 and 3, if you're numbering left to right, you'll see that we're getting pretty much and statistically comparable results with conventional. So we're getting the same yields, the same sort of tuber count, but with much less inputs. The other two, where we're getting the larger graph, is where we've used the biologicals instead of the conventional chemical treatments. We had higher tuber numbers, higher overall yield, and higher marketable yields, and indeed better skin finish, and also, of course, significantly lower costs. That was a very encouraging set of results from that set of trials. We've developed the trials into the following year based on the successes we had from these trials and from pot trials, which were indicating the same sort of thing, and to be frank, also what we've been doing commercially, which follow this pattern too. And I'll hand over to Chris in a second, but this is the trials we did subsequently in 2024 at Colwith Farm Potatoes, where again we had strip trials, and again we're looking at lower inputs at the beginning in terms of base fertilizer, and different combinations of what goes in at planting and what goes on the leaf or not. So, Chris, perhaps you could. I'll keep the clicker if you want.
Good morning, everybody. So my name's Chris Dustow, as he introduced previously by Simon. So I'm a fifth generation farmer down in Cornwall. We've been growing potatoes as a family for over 100 years now, mostly processing potatoes. So we would produce around 7,000 to 8,000 tons of, like I say, mostly processing style potatoes. We were lucky enough to be asked to be part of the TRIP project. So we've been working closely alongside Emerald and Dyson. It's been a 3-year project. So we've been gaining quite a lot of knowledge year on year. What we were quite conscious about from the start was to not make too many drastic changes. Obviously, we get a lot of different seasons, as you all know. Wet seasons, dry seasons, and all the rest of it. So year one was a bit of a learning curve. We didn't know a great deal about the project. It sort of started, we were quite late in the season. So we thought, right, we had a bit of a plan, and we actually had a chance. It was the last field we planted in the planting season. So it's probably beginning of May that first year. And we actually went down the sort of semi-organic route. Obviously, there's a lot, people talk about the organic a lot. It's not something we've done in the past, but we thought, right, we'll start with an organic variety with the help of Bangor. It was a variety called Axona. It was actually a red potato. So it had been bred for its blight resistance. That was obviously its strong point. It was a universal variety that could be a good all-rounder, which is useful in our business because we've got our own farm shop and several local outlets. We do a lot of bagging on our farm, so we knew that at least if we ended up with a product that was versatile, we probably could sell it. So we actually grew this crop in year one with just farmyard manure on the field. Compost, we use quite a lot of compost. We've got a green waste yard not too far off the farm. So we literally put 0 fertilizer in the seed bed. We just thought, right, we'll give it a go. We've got nothing to lose. And then we followed a nutrition plan only because they were, the variety was being sold that it didn't need blight spraying. So we thought, right, that's a good thing to, we can give it a good test. So we actually use one of Simon's products, the Diamond, as our blight program. And we would go in with the Diamond every 7 to 10 days. Year one, it was a relatively blighty sort of season. Not the worst we've ever seen. And I knew it was going to be quite a short season. Obviously, it's rapid growth because they went in May. And yeah, they did stand up to that particular crop. It received one weed spray at the start, along with the rest of the field. It was only a small strip. It was actually a headland in the field. And it was just easy to sort of blanket weed spray the field. And then they had the Diamond program right through. And then we did use a few of the Emerald biostimulants, sort of liquid phosphates and nitrogens, a few bits and pieces. Then they were desiccated. They would have received a blight spray on desiccation. And yeah, harvested, came in. They weren't a huge yield, but obviously they were very, very low input, sort of medium-sized tubers, what I would sort of describe as like a crisping size sample. Yeah, we actually bagged them all up, put them in the farm shop, marketed that product as a semi-organic, low input potato. And because we are face-to-face with the public, it was quite sort of positive, to get people coming in and saying, oh yeah, we'll pick those over your traditional sort of Wilgers, Sagitas, whatever other varieties are up in the shop for sale. And yeah, they went down really well to the point where actually the following year people were coming back saying, "Oh, have you got any of those Axona potatoes? They were really good." And so that was a positive and a good learning curve. Year 2, so we had a lot more time to plan. We went up to Dyson, had a few meetings, looked around what they were doing, and we thought, right, if we are going to do this from a sort of commercial business point of view, we need to sort of upscale the trials and move on to a variety that we're obviously like mainstream selling. So year 2, we chose a variety called Endeavour. So it's a crisping variety, as some of you will know. We would grow up to 100 acres of Endeavour in a growing season. So we thought, right, this is a good chance. It was a real good one because on our farm, I think in one of the pictures you almost see, we've got a shed and a sprayer fill bay in the corner of the slide. So we could literally fill the sprayer, drive into that field, and then spray each individual strip. So it was sort of like the perfect chance to really give this job a good go. And that field was quite a strong field, like indices wise. It's on our own farm. It would receive a lot of compost. It's in our own interest to feed our own farm well. We rent a lot of ground. In general, we probably grow 5-10% of our overall acreage on our own farm. So what we tend to find is when we're going out renting land, as you do this, we tend to pick up the poorer end of it in some cases. So we're conscious we're having to feed crops pretty heavily, but we want to feed them with enough fertilizer, but obviously not leave loads behind, because that's not a great benefit to us. So as a goal, we try and leave a field as we found it within reason. But yeah, here this would have been indices of like 2s and 3s. It did receive compost pre-planting, and then we went down, as you can see on the slide, 50% base fertilizer. So our fertilizer system is 100% placement on the front of the planter. So just a simple Grimmy front placement box, mostly with a product Yara main crop or a compound from Origin, similar indices or indexes. And yeah, we simply just, rather than if we were, well, we use Simon's complex soil analysis system for the second year as well. So we've got a good guideline of what the field needs and what it's doing. But we, followed the regime of sort of probably 500 weight an acre, let's say. It might have been 4 to 5 it would have been on this particular field. And then just, topped it up with, as and when, with liquid nutrition. We found that we've seen some good results from using the liquid rather than the granule in a dry year. Obviously, the granules aren't being taken up as fast. We've been using 2 different types of liquid phosphates with the planter. What we did do in 24, which was quite a radical change, is we changed over to a product called Consortium at the time. So that's been sprayed on the seed with an Amistar kit. And we've completely stopped using, obviously, Monster N got taken away. Rhino took over from Monster N or was available. We weren't great fans of using Rhino. So in 24, we actually took Rhino completely out of our plan and just used the liquid or powder nutrition and put it across all our acreage, bar a couple of these strips in the trials. Because we'd used Rhino the previous year, we thought, right, we'll give it a go again. But as you can see, we learned a lot regarding the Rhino product. Had a big negative effect on the blight overall. It was sort of from the get-go, it just proved how important it was, that habitat for that seed from the very start. Like I say, I would say the 2 products, some liquid phosphate and that powder Consortium, made a huge difference. And from a yield point of view, it was a lot more interesting to sort of see the different strips going across. You could just, you could tell that it was from a cost point of view as well. obviously we kept the cost down, and we had some really good yields from reducing our fertilizer usage on that field. That was a commercial crop. It got sold. Yes, there was extreme blight in strip 4, but it looks accelerated slightly there because they were topped off, and that all got sold. Went to a local crisping company. So we learned a lot from that trial that year, didn't we? It was good progress. The third year, we were actually out on rented land. It was ex-organic land in this case. Poor indices, sort of 1, 2, 3. Again, used Simon's complex soil analysis from the start. As you'll know, last year was a pretty dry season. Cornwall fared probably as good as anywhere regarding rainfall. But we did our usual sort of set out the strips, quite similar to the previous year's trials that we just looked at, but we did decide to not use the rhino powder at all in this situation. So we set out 50% cuts back again in the fertilizer in the seed bed. We did have a traditional, as always, one that received absolutely everything. That year, like I say, was dry. Again, totally different. That's why it was important to do it over 3 years. We looked at the results at the end from a yield point of view. We sort of dug the strips. We've got a weighbridge, put them over the weighbridge. The conventional did come out on top in this case. It had the full fertilizer program, full blight sprays, didn't actually receive any foliar nutrition on that strip, but we learned that Taurus in a dry season is a hungry variety. So it did come out on top on yield. We're yet to sell that crop yet. It's in store, obviously, for a minute. But what was really striking in this particular trial is some of the strips that did only receive 50% fertilizer did not receive one blight spray at all, other than on desiccation. It was an easier blanket program to go in, desiccate the field down. But you're sort of talking about strips next door that had 12 to 14 passes with the sprayer putting on fungicides. Our customer base, they are looking more into, like as Simon mentioned, carbon footprints, cutting chemical usages, nitrogen and phosphate leaching, obviously becoming a big problem. So, we've learned a lot, and it's quite something nice about I drive one of the sprayers a bit, and there is a nice feeling about pouring in a product that's just more of just biostimulants rather than fungicide after fungicide. Obviously, we all used to spray every 14 days some time ago. Then it went to 10. Then it went to 7. And then you sort of think, well, where are we actually going here? Are we going to be down to 4 days in a minute? So the trial has been really good for sort of being able to go out. It's not big acreages, so it's nice strips, manageable. If you get a problem, as you can see, you can top it off, you can manage it. So it's been a good learning curve. We've had a lot of interest in it. Been working with some other local growers, and it's been nice to speak with the other growers as well. Share your thoughts, views, results. They can, they're on slightly different soils and whatnot. Some of them are on salads. We're on obviously a processing material. It's been a real good learning curve moving forward. We've got some good ideas. We can do introduce more of perhaps the diamond product, perhaps stretch some blight sprays out to 10 days. We maybe do some alternation of blight spray 1 week, diamond the next, and just see how we go really, and try and take some of our learning into the future production. So I think that's about it from me. Thank you.
Thank you very much, Chris. That's great. Really, really detailed explanation of the trials that have been going on, and really interesting how that's evolved over the last 3 years. And as Chris says, there's things we've learned and which have been very positive, and a couple of things which we know we need to improve upon in subsequent years, but all part of the learning curve. Just wanted to cover the sensor grower Knox box before I move on to Katherine's part, which is about plant breeding. Essentially, we've been developing this device. It started as a prototype back in 2020, I think 2020, yeah, in a previous project. The concept was the fact that we were looking in that particular trial at being able to measure nitrous oxide emissions in the field, and then discovered that there was no device in the world that could do it. So we had to set about inventing one, which we've done, and patenting it, which we've also done. And Light Science Technologies got involved a few years ago, as they have a professional printed circuit board company and make a whole range of high-tech horticulture and agricultural equipment, and they have the right team and resources to do it. To transform it into the device you see behind me. The device, as you can see, sits on the soil ridges, and can be set to monitor greenhouse gas emissions in two different sets of quantities in 0 to 1,000 parts per million and above 1,000 parts per million. It can be set to measure from anything from once every 5 seconds to once a day. We normally set it at either 10 minutes or 30 minutes. And that data is recorded. It sits in the field without any intervention, runs on a battery, and that battery will last 6 months because it's an extremely low power device. So it doesn't need solar panels and all that sort of thing. It's very robust and can be just essentially placed in the field and moved around. And we're using that in conjunction with the software systems we've developed as a ground truthing for an entire crop or farm area with other devices. You'll see there that there's a couple of graphs there. They are from different soil types where the device has been left to chug along. And one of the most important things you'll see is the peaks. And this is one of the very first discoveries we made, as it's running 24 hours a day and measuring every few minutes. One of the things we found was that we got daily peaks in nitrous oxide, and nitrous oxide emissions were significantly higher at night, which is a complete revelation. And it literally, down to the minute, is the second the sun goes down, the peak starts to rise, and the second the sun comes up, the peak drops again. We are speculating, but we believe that it's because the plant is turning from chlorophyll into the photosynthesis during the day into assimilating the carbohydrate it's gathered during the day, and therefore the soil bacteria have evolved probably to take advantage of that gap between dusk and dawn to start using nitrogen sources and produce nitrous oxide. We simultaneously also find the same thing seems to be happening with CO2 as well. So that again would tend to suggest that is a great deal more activity going on in the soil during that period. The graphs show different soil types and the way those peaks perform. The top one was actually where some nitrogen was applied on the slope above the particular trial site here, and we then this is 24 where we had quite a lot of rain, and literally a week or so later started picking up nitrous oxide emissions down the slope where the devices were, as the nitrate was obviously moving down the slope and being assimilated, and nitrous oxide was being given off. So that was quite an interesting outcome. You can also see where we've got devices together in that bottom left-hand picture. We're just literally putting them together just to see what the variation is over a very small set of distances. They give very similar outputs when close together, but obviously you do get variations within the field, which comes back down to the satellite imaging we're doing as well, which allows us to use this being ground truth in one part of the field and then seeing the variation on through various wavelengths from the satellite imaging to be able to essentially use that as a benchmark for the whole field or whole area. That's all I really wanted to say, but one of the things we did find is that the fluctuations are quite, these daily fluctuations are real. We've seen them take place on any soil we've tried it on, but when you put it over things like concrete or anything else, nothing, flat line. But it's essentially diurnal. And also interestingly, we've run it over the winter. The peaks are much less high, but much longer because day length is shorter and the night is longer. So the peaks, again, exactly match dusk and dawn, but are much lower rather than high peaks. But again, we see exactly the same thing happening there, which again, I don't think has been previously recorded. So that's something we've discovered from this. I'd like to hand over now to Dr. Katherine Steele to talk about the plant breeding that they've been doing in conjunction with the JHI in Scotland.
Thank you, Simon. Hello, everybody. So my part of the talk today is about the work that we've been doing on the TRIP, Transformative Reduced Input Potatoes project at Bangor University. So the partners on the breeding component of TRIP, and TRIP is a very wide-ranging project, and we have many different components that some of which you've heard about, others more, say, working with mulches and so on at Dyson have been going on as well, plus other work on greenhouse gas monitoring with a different system at Bangor University to compare these two systems. So it's a diverse project, lots of different ways that are being trialled to see how we can reduce overall impact on the environment and improve the ways that farmers can adopt to transform and reduce the impact of potato production. So our component is the breeding work package, and the partners on that were shown on the original slide from Simon. So Bangor University leading the work package with the James Hutton Institute, and that is Professor Ingo Hines' team up in Dundee, who've been fantastic on this component. They pioneered the DREN-seq, direct R gene enrichment sequencing protocol, which is really useful for identifying which resistance genes are in a particular potato clone. And then the other partner that's really important on this project, who's based in Bangor University, is the Charvery Research Trust. And they are the breeders of the Sharpo potato varieties. So SRT, Charvery Research Trust, began in 2002. They started with a collection of germplasm from Hungary, from the Charvery family. And these have genes for resistance, not just to late blight, but also to some important potato viruses. And they were derived from the original collections by Vavilov, the famous Soviet-era plant collector who collected diverse crop wild relatives from all of the centres of diversity of crop domestication. So he had put there's really fascinating stories about these collections during the First World War, where people the scientists were not eating these special clones so that they could be there for future generations. So the Charvery family passed on this valuable collection to David Shaw, Dr. David Shaw, who runs SRT. And he then took on and commercialized the first of the varieties, which was Sharpo Mira, which is the most famous. There are now 5 other varieties of Sharpos that have been commercialized. And we've already heard about Axona from Chris. So the USP of Sharpo varieties is that they have blight resistance, and they tend to be popular among home gardeners, amateur growers, allotment holders, and organic growers in particular. Now, Bangor University were approached by Dr. David Shaw, who incidentally is a retired university lecturer from Bangor in plant pathology, to help them breed the next generation of Sharpos. And so I took on that responsibility as a supervisor for a PhD student that was funded through an industrial partnership with SRT and Bangor University to screen potential germplasm that could bring novel additional resistances to the Sharpo family by making crosses between Sharpo and other varieties. So the top left-hand box shows the origin of that, making crosses in 2017 after that student had identified using some DNA markers, lots of networking to find out what our genes were like to be in them, and detached leaf assays with the current, at the time, isolates. So we ended up with 3 Dutch variety parents and Sharpo Mira and Axona as being 2 Sharpo parents. Those crosses, reciprocal crosses, were made for at least 3 different combinations of those 5 varieties, always with a Sharpo and a Dutch variety. Those were then advanced, and we had we started off with literally thousands of progeny. It was a very small scale, 1 PhD student. We were not able to screen all of those. So we had to basically grow them in pots and use detached leaf assays. And then we started growing smaller scale field trials with the best ones from the selections from the detached leaf assays. So that started around 2018, the first time we did a replicated yield trial, blight trial, in our Henvice Research Centre farm, where we always have a natural population of blight that arrives. It arrives locally in the allotments nearby. And so when that appears, we know that it's okay to help it along. We have spreader rows of Blue Danube, which is another Sharpo variety that has foliar blight, but not tuber blight. And so we use that, and it's also got a purple colour in the stem, so it's very easy to spot as a spacer and as a spreader row as well between our plots. So we always use that in our trials in Henvice in Bangor in North Wales. So yeah, those original experiments were done up till 2022. This is one of those early experiments. You can see at the bottom here, with some examples of clones that were highly resistant and some control varieties, or some of the clones that then did go down in the field. So they were immediately rejected from the breeding program. So we didn't bother taking any clones forwards if they had any form of blight in any of our detached leaf assays or field trials. So then in 2023, the TRIP project team all came together, and that allowed us to have 3 years of funding to continue these trials and work with the James Hutton Institute to do the DREN-seq DNA analysis on the clones. So in those 3 years, our trials became much bigger. They basically took up much more area and became very well organised. We had a trials manager, Sarah, who's looked after those trials very well for us. The other thing that we did was we included potential parents from for other potential traits that we want to include. So that is some abiotic tolerances as well as biotic tolerance or resistance, and better quality eating and processing traits as well. So it's kind of tough to be able to, on a small scale, to be able to include all of those in a breeding program. So the idea being that we would get data on all of the potential parents and then use that in modelling going forwards with the James Hutton Institute to try and work out best combinations of crosses for the future, including what we then ended up with were the 16 clones that came from our original cross. Down here. So we had over 80 varieties growing in our trials in 2024 and this year 2025. Now the bottom left-hand graph shows it's quite an old slide now from Ingo at the James Hutton Institute, which shows in the bars that are split between red and blue. So the first bottom set are resistance genes against late blight that are pretty much deployed. So the cultivars are shown in blue. So where they're deployed in cultivars, you can see them, and where they're in breeding lines, they're in red. Most of those on that first block have been broken down. The second two blocks coming in, you can see there's very little in cultivars. Those are resistance genes that can be deployed, that are being used in breeding programs, that are in some varieties now. And the idea is to stack as many of those into varieties. Not all of the resistance genes that we know about in our 5 parents are shown on this graph. There are other ones that we know of and have markers for with the James Hutton Institute. And then we come along to the PCN resistance genes, which you can see the H1 is quite widely deployed. And then you've got the pallida resistance genes that are starting to come through. And we've got some of those in some of the material that we're working with in our breeding program. And then finally, you've got the virus resistance genes. And again, there's some extra that we're not supposed to mention that aren't there. And so what we've actually found in our, when you look at the DNA markers, is that from these crosses, of these 16 lines these clones that we've selected, we have got very interesting combinations of not just late blight resistance with some of that middle set that haven't really been used yet. Different combinations that the James Hutton people hadn't seen before, but also some of the virus and PCN combinations as well. But they're in different clones. So we've got combinations that are unique in, say, 2 different clones, and we would then like to combine those in the next generation, plus those other traits. So that is kind of for the future. We also found, interestingly, in the 2024 trial, that the if you do blight, a scale of blight, the ones that tended to have no blight, obviously our clones are down this end, and then the varieties, the commercial varieties, tend to be more at the getting blight end. And then if you look at the graph for yield, it's kind of the other way around, but there are 3 varieties, 3 clones from our breeding that are clearly on the higher yield end as well of that graph. So, disappointingly, a lot of them were low down. There were 2 that we call CAX1 and CAX13 that were particularly positive. They'd got the nice white skin colour and the flesh colour, and CAX13 was a bit earlier. CAX1 was a bit later. But but they were really, really good for blight. And we took them both to the Potato Days Europe and also to the Eurofins blight trial, where they stood up really well. There were the only other person there who asked for no blight program was the guy from Ski Organic. We had asked for no blight program, and people just looked at them and said, well, that's amazing that these weren't sprayed, because it was a really bad year for blight. I don't know if you went to the Eurofins blight trial last year. It was pretty shocking. And as we're standing there next to the strip that had gone down, so we feel really proud that we've managed to do that on a small scale university partnership project. I say it's a long time to do this. And we're then hoping that we can take these forwards and do some genomic selection work to actually improve on where we've got to, and hopefully get some varieties that David Shaw and SRT can release and hopefully be taken up by Dyson as a environmentally friendly potato variety in the future. So with that, I shall hand back to Simon. Thank you.
Thanks very much, Katherine. That's really fascinating, and it's been fascinating to watch how that's developed over the last 3 years in the TRIP project, and it all comes together as yet another component driving towards sustainability of reduced inputs. I just wanted to put this slide up, or frankly, Graham asked me to put this slide up, for the taking part in the National Potato Industry Confidence Survey. And if you could potentially scan the barcode on there, which will take you to the relevant place, and do that, we would be very grateful. He would be very grateful too. And I'd like to thank GB Potatoes for putting this on and for giving us the opportunity to talk to you today.